Question 18. Chris started to make this pattern of shapes using matchsticks. If the pattern of shapes is continued, which shape would use exactly 486 matchsticks? The first thing we need to establish is the relationship between the shape number and the number of matchsticks used to make that shape. And that's summarized in this table here, where S represents the shape number and N represents the number of matchsticks used to make that shape. So when S is equal to 1, N is equal to 6. When S is equal to 2, N is equal to 10. And when S is equal to 3, N is equal to 14. So from the table, we can see a pattern that when S goes up by 1, N goes up by 4. So a linear relationship exists between the shape number and the matchsticks used. And the linear equation will be of this form. N equals 4S plus some constant C, which we will need to find. And the 4 here comes from the fact that as S goes up by 1, the number of matchsticks N increases by 4. And if this was graphed, the 4 represents the gradient of that line. So the next thing we need to find is the value of the constant C, which represents the y-intercept if this equation was graphed. And we can use any column of the table to find the value of C. We know that when S equals 1, N is equal to 6. So if I substitute S equals 1 here, we know that N must equal 6. So 4 times 1 is 4. So what do I need to add to 4 to make this 6? And we know that C must be 2. So the equation now is N is equal to 4S plus 2. The final step is to solve for S. The equation 486 is equal to 4S plus 2, where this represents the number of matchsticks used to make that particular shape. So we need to find the shape number that corresponds to 486. So solving this equation, we're going to subtract 2 from both sides of the equation. So 484 is equal to 4S, which means 4 times S. And to make S the subject, we divide both of these values by 4. So 484 divided by 4 is equal to 121. Therefore, S is equal to 121, which corresponds to the shape number. Therefore, the answer is option C.